All right, so I think the main thing to note about section 11.1 as we begin the non-parametric test is that we start the sign test by doing this comparison. So whatever we are testing against, we compare our data values to that, and we determine if we are above the median that's claimed, below the median that's claimed, or equal to the median that is claimed. And when we do that, a couple of things to note. Number one is that the zeros should be ignored. So anything that's equal to the claimed median is ignored, and that does affect the sample size. The other thing to note is that we always define x as the smaller number of plus or minus signs. Now, when you do that, for a test where the sample size is smaller, specifically less than or equal to 25, this is a pretty simple test to run. And that's what happened in the first example here. This was the first example that was completed for you if you watched the Learn the Content video. And in this one, because we had a small sample size, specifically the sample size turned out to be 23, which is less than 25. All we did was use the smaller number of plus or minus signs to be our test statistic, and we compared it to a critical value that is specific to the sign test. Now, when you have a larger sample size, this is actually going to turn into a z-test, meaning it's going to use the standard normal distribution. And because of that, in that case, you have to actually convert the value of x, which you're seeing again right there, to a z-score. And you're going to do that by use of the formula that you're seeing right here, and then you'll compare it to a standard normal distribution. So again, this first example and the last example, those were both covered in the Learn the Content assignment. But this one in the middle, where it switched to the standard normal, this was not a part of that. So I wanted to go back and make sure that I looked at this particular question with you. So starting out, I'm going to define my claim. All right here, I'm looking at a claim about the median value. Specifically, we're claiming that the median is 9.4 years. So pretty straightforward setup. The null hypothesis contains equality. It will state that the median is 9.4 years. That will be our claim. And the alternative hypothesis will be the opposite, that the median is not 9.4 years. All right, now the other thing to notice here, a lot of times when the sample sizes are larger, instead of us having to compare each individual value, the comparison is done for you and it's summarized. So just keeping in mind what a plus and a minus means. We see here that we have 41 automobiles that were less than 9.4 years. We assign those minuses. And we have 51 automobiles that are more than. We assign those pluses. So that means that our sample size n, right, disregarding any zeros, our sample size n would take the 41 values that are below, add in the 51 values that are above, and that would give me a sample size of 92. So even though we took a sample of 95 automobiles up here, this means that 3 of them had a median that was equal to 9.4 years, and that's why those values are being disregarded. Now, what's important for me to note here is that this is a case where n is greater than 25, and that means this is going to be done as a z-test. All right, so what I'm going to do first is I'm going to determine my critical values and my rejection region using the standard normal distribution. So here's my bell-shaped curve. Now, this is technically a two-tailed test because we're testing not equal to. So to find my rejection region, I'm going to shade a two-tailed rejection region, and I'm going to use alpha over 2 as the area. Alpha here is 0.10, so I'm going to use 0.05 to find my critical value. All right, and you guys are well aware of how to do this. So I go to the table, or I go to the normal calculator, and I determine, this is one of those special cases, that my critical values are negative 1.645 and positive 1.645. The other thing that I'll just mention to you here is because of the way the decision is made in this non-parametric test, if we just kind of refer back here, you're always looking to see if your test statistic is less than or equal to the critical value. And so many times when you look at your rejection region, all that's shown is the left-tailed portion of that rejection region. So if you're ever doing the sign test and you notice that even though it's a two-tailed test, you're only asked for one critical value, this is why. Because, like many of the tests in Chapter 10 were always right tail, the sign test is essentially always a left-tailed test based on the decision rule that we're seeing here. All right, now the next thing I'm going to do is use my formula right here to compute the z-score that we will use for our standardized test statistic. All right, so my z-score formula, see, we're going to take x plus 0.5 minus 0.5 times the sample size. So let me go ahead and write this down. So our value of z will take x plus 0.5 minus 0.5 times the sample size n, and this will be divided by the square root of n over 2. Now, you do want to be careful when you go to put this in your calculator to make sure that you compute it correctly. But first, what I'm going to do is just plug all my information in. Now remember, x is always the smaller number of plus or minus signs. So x in this case, the smaller number of plus or minus signs is 41. Plugging that into my formula, I'm going to add 0.5. I'm going to subtract 0.5 times n, which is that sample size disregarding the zeros. And I'm going to divide this by the square root of n. There's that 92 again. Divided by 2. Now, the main thing when you go to compute this, if you want to plug it all in at one time, is that you would need to have your whole numerator in parentheses, and you would need to have your whole denominator in parentheses. The other thing to do here is to kind of work it out in pieces. Just make sure that you don't round too short. So for example here, right, I could go ahead and note this is just 41.5. 0.5 times 92, right, we're just taking half of 92. So we're looking at a value here of 46. And then if I go to my calculator and work out that denominator, the square root of 92 over 2, I'll take 92 and the square root divided by 2. That's a value of approximately 4.7958. So if you find that easier, then you can definitely go through and evaluate this in pieces. So that would mean I would take 41.5 minus 46, and then I would divide that by 4.7958. And that's going to show me my z-score, rounded to 2 decimal places, is negative 0.94. So again, when the sample size is more than 25, rather than just using x, the smaller number of plus or minus signs, and the table that's designated for the sign test, we transform to a standard normal. We calculate a z-score. We compare that z-score to our rejection region. And essentially, yes, we are looking to see, does it fall in the shaded region? It's just in this case, we're always going to be looking on the left side to see if that happens. So negative 0.94 is going to be up here somewhere. The main thing to note is it is not in the shaded rejection region. So I would fail to reject the null hypothesis. And that would tell me there is not enough evidence to reject the claim because our claim is in the null hypothesis that the median age for automobiles in operation is 9.4 years. So when it comes to claims that are testing a specific value of the median, right, you're going to see one of these two cases, right? The smaller sample sizes, simple X value, simple critical value. The larger sample sizes, everything has to be converted to the standard normal. And then the last thing in this section is using the sign test to compare two data sets, paired data essentially, and this one's typically called the paired sample sign test. And this was the other example that was shown for you in the Learn the Content video that was produced by the textbook. So again, if you have not watched, I think most of you have, but if you have not watched that video already under Learn the Content, be sure to do that to fill in the rest of your notes, and then get to work in your practice problems and your demonstrate problems in section 11.1 and reach out to me with any questions that you have.